So to start with, we have coterminal angles. This is an old thing. I talked about it already once. We do need to get better at it, but and we have given an angle, identify all 6 trigonometric functions. All right, so this has got some new stuff in it, but it's a lot like the trig we just did. Overall, your test scores were good. Your class did significantly worse than my other class, just saying. My other class, the average was a 95. Okay, so this can be easy, but some of you guys didn't do so great. And I would ask yourself, like, did I do my homework? Like, if you did your homework and you still had, major struggles, then hey, I understand this is hard. But for some of you, it was because you didn't do the work. You don't practice, you're not going to be good. If you're talking about flute, and you don't practice, you're not going to be good. Same thing with math. So ask yourself, did I do the practice? All right, let's move on to page 2 here. Everybody look at that. Would you agree that both of these angles end in the same spot? They both end right there. Welcome back. I had you marked absent, so remind me later that I think you're here with... No, actually, the news show is 10 minutes long, so you are later than 10 minutes. That's depressing. Okay, so anyway, back to this. That spot right there, that's where they both end. That's called coterminal. There's 2 different ways you could say that spot. You could say 120 or negative 240. Now I want you to do it in radians. Hint, 120 is like 260-degree angles, isn't it? And 60-degree are one of the ones you're supposed to just memorize. Like, oh, that's pi over blah. If you haven't got those memorized yet, they're not on the board anymore because we had a test, but you got to know those. 60 is pi over 3, and if you didn't just know that yet, you got to get this on a flashcard, and you got to make flashcards. So that spot is 2 pi over 3. Could you do it another way? Yeah, but I think it's clunkier. You could have done the whole, like, multiply by pi over 180, but I think that's kind of slow and clunky, because then you got to reduce 120 over 180. It ends up being 2 pi over 3, but... All right, and then just think, if this is in pi over 3s, well, then this could be in pi over 3s, just negative ones. That's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 in the negative direction, negative 4 pi over 3. Is that making sense to you? All 4 of those things end in the same spot. 2 of them are in radians, 2 of them are in degrees. So, can you do that? Graph all 3 of these. 2 of them will be in the same spot with each other, if you're doing it right. So I would ask you to use 3 different colors. Use black for the first one, use red for the second one, use blue for the third one. So make a black line where 30 degrees is. Make a red line where negative 330 is. And make a blue line where 450 is. One of them will be in a different spot. That means 2 of them are coterminal. They share the same terminating spot. If you don't know what I'm talking about at all, here's where 30 degrees is with a black line. Then you should do that same kind of thing for negative 330. If I'm ever really close to 360, I just go to 360 and go, well, negative 360 would be here, but then it's not quite that far. And you back off and go, okay, not quite that far. Ooh, it's actually in the same spot. It's right there. I'm not going to go on my black line. I'll go right over the top of, like, so that they're both there. Here, I'll draw the black line. They're both in the same spot. That means 450 must be somewhere else. So I'm going to make that one in blue. And that's 360 plus how much more to make 450? Anybody figured out yet? 360 plus 360 plus 90. Let's just make sure. 360 plus 90. Does that really make 450? Yes, it does. So I'm going to keep going up to there, and that is where 450 lives. Do you get how it's not coterminal with the others? Now, would you please label those spots in radians? This has to be like, boom, radians. Easy, I got radians down. Whenever I do radians, I slap a pi here so that I can think, okay, let me think. Oh yeah, 1/6 of the way to pi, pi over 6. And then the blue one, what do you say? Half of the way to pi. So pi over 2, or 1/2 pi. Okay, on to the next one. I don't think we need to practice these anymore. I feel like you've got this, and it should be pretty easy. If you need more help on those, come up after in the work time. All right, the 6 trigonometric functions of this angle. But the weird thing is you don't know what the angle is. All right, so off to the side, I want you to draw this. I said we would draw about 100 of them. So here's like our 10th one. And I'm going to show you, this is one of those moments where I take an extra second to just try to explain, and instead of just memorize this, why it works. If I wanted to make a triangle to this spot right here, would you agree I would probably connect that, and that would be called the radius. Let's label it R. And if I was going to this spot right there, I would drop to the x-axis and I would say that that is another side of the triangle, and that's y values are up and down, so I'm going to call that y. And last, to connect it, I'm going to make this green side here, and that would be x. Do you get I put the x because that's on the x-axis? And the y is going up and down, so I labeled it y. All this makes sense. The r is called r because it's the radius. Does all that make sense to you? Then, right here is the key angle, because why? Because it's always right there. It's called the reference angle. So label that. If you stop drawing, wake up, draw this. My lesson will be very important today. Stay with me. We'll have a lot of work time. You can rest then. All right, so now, of course, we're doing trig, so it's probably going to involve trig functions like sine. So everybody write that here, sine of theta. And we'll just use letters, and it's okay. We'll use variables. We don't have the numbers, so we can do sine with a couple of letters. Remember, this is the angle, and some of you guys got twisted on the test, and you thought we flipped over angles. We don't. Never flip an angle. You do flip sides. We flip sides over sometimes, but we never flip the angle. All right, this is the sides right here. This was an angle. The angle is the thing that goes right after the trig word, the trig function. And that is side ratios. For all trig, you always have your angle here, and this is always 2 numbers. You might be like, no, sometimes it's just 1 number. Well, if it was just 1 number, like it was 3, then you could put it over 1, and then you got 2 numbers. Do you get how you're always going to have a ratio, and therefore you always can say there's 2 numbers there. Even if there's only 1 number, put it over 1, you got 2 numbers. Okay, so sine is opposite of hypotenuse, isn't it? I keep coming back to that. That's one of the 20 things you got to know from trig. So katoa. So sine is opposite, which is y over r. That's 2 sides in a ratio. I bet you can guess what I'm going to do right here. What do you think I'm going to do next? Cosine. Your cosine will be what over what? Adjacent over hypotenuse, ka. And that's, in this case, x over r. Very good. And then the last one will be tangent. And I hope you memorize that that's toa, opposite over adjacent, y over x. Now, this is the point where I'm trying to show you why you need to know these, but now you do have to memorize them. Sine goes with y, and then it's over r. Cosine goes with x. That's the strongest connection you want to have, is that sine goes with y and cosine goes with x. And you'll just try to remember that you're dividing by the hypotenuse, which is the hypotenuse is the radius, so it's going to be over r. I don't care how you memorize it, but you've got to memorize it now. This is out of 20 things you have to memorize for trig. Here's another one. That's why I said flashcards would be smart. Sine is y over r. Cosine is x over r, and tangent is y over x. So now that we know that, this problem is going to be super easy. Would you please make me a triangle around this thing? And you know 2 of the sides. Don't you know that to get to 3 comma 5 you had to go over 3? And to get to 3 comma 5 you had to go up 5? Do you get we have 3 and 5 on the sides of our triangle? Doesn't that make sense? By telling you that point, they gave you 2 sides of the triangle. And you were trained how to make this a square root of 3 squared 9, 5 squared 25, longest side, add them. I think it's 34. Did anybody else get 34? Okay, good. So square root of 34. Now that I've got that, I'm ready to do my sine, cosine, and tangent. What's the key angle? That one. It's always the one by the central. That's why we call it the central angle. And it's also called the reference angle, especially when it's in another spot on the triangle. You just always pick the one by the center is the reference angle. And sine is, do you have a short-term memory? What over what? Y over r. And so in this case, what's y? 5 over what's the radius? Square root of 34. Now again, did I just figure out the angle? No. I figured out the side ratios. I have no clue what that angle is. That's a different unit. I'll show you how to figure out what that angle must be, but that's a different unit. Right now, we just care that you can get this side ratio, and I don't memorize the 3, 5 square root of 34 triangle. You know, if this was the 1, 1 root 2 triangle, we'd know it's 45, but it's not. So we don't know the angle. And again, some of you, when you do like cosecant, some people flip the angle over. You're not supposed to flip the angle over. Theta is still theta. It's not 1 over theta. But you are supposed to flip this part over. So it's root 34 over 5. So remember how sine and cosecant is another one of the 20 things you have to memorize for this unit? Sister function. Sine goes with cosecant. So I'm going to do this one. Cosine goes with, say it if you know it. Secant. Very good. Would you please now figure out what those 2 answers are? What's cosine? You have to memorize something. That's why I'd make flashcards. So many things to memorize. Do you know they did a big study on flashcards? And flashcards had a way stronger impact on memorizing something than reading over your notes. It was like literally quadruple the retention rate if a kid used flashcards versus another kid who just looked at their notes. Way, way, way better. So, encourage you to do that. So cosine is x over r. And so x is 3 over r is root 34. 3 over root 34. And then I just flip it. Notice I'm not flipping the angle. I am flipping the side ratios. And last but not least is tangent. And what's its sister function? Cotangent. And tangent is, if you memorized it, TOA, opposite over adjacent, y over x, 5 over 3 in this case. And then cotangent, just flip it. Notice I'm not flipping the angle. Okay, There you go. That's how you do it. It involves a ton of little things. That's what trig is like. So many little things. Like you have to know sine, cosine, and tangent. So, ca, toa. If I just take that away from your brain, boop, now you can't do trig anymore. Like if you don't have that memorized. Now I just added a new one for today, and that was these. And again, for your next test, if I took that out of your brain, you didn't have that memorized, you couldn't do them. Another thing you got to know is how to find the third side of a triangle, like this square root of 34. If you still don't know how to do that, it's these squared and added if you're on the longest side. But you got to have the square root there. So many little things. Moving on. Everybody find this. And I don't want to do all 6 because it takes too long. Would you just please find sine and its sister function? But there's no triangle. Well, then make the triangle. Label all sides. Now, the fact that you are working right now and trying this means you're going to remember it way better than if I just had you watch me. I always get struck by that 10% number. Man, you only remember 10% of a speech somebody gives. But by you doing it right now, I bet you'll remember how to do this. This will be a -3. Notice it's negative. This will be a 5 because it's going up and it's positive. And then the hypotenuse, remember the hypotenuse? Also known as the radius of the circle. If I put a circle around this, that thing has got to be positive. Don't forget that. It's going to come up today. All right, so then it's square root of 25/9. Ooh, I feel like I did this one before. Square root of 34, right? Okay. Sine is opposite of hypotenuse. So therefore, sine from this perspective, remember, here's the angle, but here's the reference we use. Sine of that is opposite of hypotenuse, so 5 over root 34. And the sister function is cosecant. And you don't flip the angle, you flip the sides. Root 34 over 5. Boom, done. Okay. This one, same exact thing, a little too easy. This one, weird, and we definitely need to talk about it because it comes up on the test. Because there's your point, and what's weird about it is you can't draw this line and then make a triangle around it. There's no triangle. But you don't have to have the triangle. What? You don't have to have a triangle to figure out sine, cosine, and tangent of this puppy. Do you have a short-term memory? Sine of the angle is what over what? Sine's y. Y over r. Boy, I don't have an r. Yes, you do. Imagine this being a circle. You know the radius of the circle. So, what's the y? Well, this part's the y, I guess. 1 over, what's the radius? 1. So the answer is 1 over 1, which is 1. You see how memorizing some stuff really, really helps? Because even though I don't have a triangle, I can go back to y over r. And I have y, and I have the radius. There you go. How about cosine then? Don't say it. But I want to warn you this. You're going to either get 0 over something, let's say 8. It doesn't matter what it is. Or you're going to get 8 over 0. And you got to remember, one of these is allowed, and one of them is no answer, no solution. Do you get this one is allowed? And it's just equal to what? Focus. What's that equal to? 0. What's this equal to? Doesn't make any sense. That does not exist. All right, so remember, 0 on top, the answer is just 0. You're going to have that come up because, you got fractions. They're ratios. And sometimes you're dividing by 0, and sometimes the 0 is on top. If the 0 is on top, it's just 0. If the 0 is on the bottom, there is no solution. So what do you write? You write no solution. Okay, so back to this. We figured out the sine. The cosine is x over the radius. This r looked like a y. I'm going to erase it and make sure you didn't think I meant this was an r. That's cosine's x over r. Well, the x is 0. Ooh, that's what you were just talking about. 0 over, the radius was 1. Is 0 over 1 like an illegal thing? No, it's just 0. And last but not least is tangent. And then, of course, you could flip all of them and do the sister functions. TOA, opposite over adjacent. That doesn't work so well in this. There's no opposite and there's no adjacent. But there is a y. What is it again? Y over x. You didn't memorize it, you wouldn't know that. Gotta memorize these. Tangents, y over x. So, I got a y, I got an x. It's 1 over 0. Is that allowed? You cannot leave your answer as 1 over 0. You have to go no solution or DNE for does not exist. Because you're dividing by 0. You've got to know that doesn't work. All right, I've covered everything. Does that mean you're awesome at it? No, this is the first day of the unit. It's always a little confusing in the first day of the unit. But if you only remembered one thing, it would be sine is what over what again? Y over what? R. Cosine is x over r, and tangent was y over x. You've got to know those. And then you can take a point which has an x and a y in it. And you can figure out the radius by drawing a triangle. Or just figuring out the radius. And then you can answer all these questions. All right, let's get to your homework. We are doing the evens. Doing the evens. Okay, so number 2. Find your homework. Find number 2. Morgan, did you read me number 2, please? You got it yet, Sabins? Wait, do you have... I didn't mean to, if you don't have it open yet, I can get somebody else. You got it?
Yeah, but did you say Morgan?
I did, and then I switched to you, Sabins. Sorry. I'm suddenly stuck. But help me. What is it? I know. Thank you. All right. So, would you read me number 2?
It is 5 pi over 3, comma, negative 5 pi over 3, comma, 11 pi over 3, comma, negative 7 pi over 3, and then comma, 365 pi over 3.
And they basically want to know which of these are in the same spot, right? Or did they say to graph them all?
It says identify the one angle that is not coterminal together.
All right, so I would start by graphing. And I wouldn't make myself graph them all, but I'd figure out where at least some of them, all of them are in the same spot except for one. So the easiest one to graph would probably be 5 pi over 3. There's pi. 1 pi over 3. I always start with that, and then I go, okay, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. It's right there, the green line. Now, are some of the other ones in the same spot? That's what you want to ask yourself. So keep going until you figure out which one's not in the same spot. So negative 5 pi over 3, where's that? Well, that's negative 1 pi over 3. Negative 2, negative 3 pi over 3, and that matches, makes sense, because it would cancel and become pi. 4 pi over 3. Negative 5 pi over 3 right away is in a different spot. But I don't know where all the other ones are. I don't know if they all line up with this black one or if they all line up with the green one, but at least I know it's one of those two spots. And then I graph the rest of them in my head and I go, oh, they're all lining up on this black one here or on the green one. And then you'll be able to tell which one's different. All right, let's go to number 4. Because number 4 is more like the whole rest of the assignment. Madeline, would you read me number 4? It's probably a point. 4 comma negative 3. Can anybody verify? Am I on the right one here? Okay, good. So 4 comma negative 3 is like a dot down here. And then I put a triangle around that. So first just connect it, and that's like the radius. And then I go like, oh, so that's 4, because you go over first. And then this green line is like the rest of it, and that's like down 3. I keep the negatives on there because it's going down, right? And then remember, the radius, the red one there, that never can be negative, and that matters. Find the third side, square root, do that whole thing. And the key angle's here, so you figure out sine of it, which is y over r. Strong recommend you draw the triangle every single time. Sine is the y, so you can't just write down negative 3. It's negative 3 over the radius, which is the same as the hypotenuse. So you can think of this as opposite of hypotenuse, or you could think of it as y over r. Either way works. Then once you figure out what this is, that'll go there. And then you figure out all 6 of them. So like sine is super easily translated into cosecant. And then whatever this answer was, I just flip it and put it there. Okay, I think you got the idea. I don't expect you to be the master of this. But let me again remind you about the value of homework. I looked at the other hours' homework. It was almost all in. Sure, there's a couple kids that slacked on the homework. But I looked at your hours' homework, and tons of it was missing. And then we got the test scores. Big surprise. The hour that almost all did their homework did really well. And again, some of you guys did fine. And I bet it goes along with you're the ones that did your homework. And I think some of you think it doesn't matter. Let me give you one last example of why homework matters. I had a kid with a straight A on their first test, didn't do any homework. What do you think their grade was? A B. That's just dumb. Takes you like an extra 10 minutes to do the homework. You're giving yourself a whole grade lower. Just do your homework. It's not that hard. I cut it down, you gotta admit. I'm giving you half the assignment. It's very reasonably sized, so your hour needs to be reminded how important homework is. All right, that's all I got for you for the video for today. Do your evens, and that's it.